I have been in this
Wait, what
chapter so
class
far.
are you recording this for?
I'm actually recording it for the people that are absent. Okay, like
One
just-
person.
Well, today I have another class. All right, so 2 to the third power. What's 2 to the third power?
8.
8. How could I write?
Good job, Mike.
How could I write 4 as 2 to what power? 2 to the second. 2 to the first power is
2.
2. Now, what's happening to the exponent as I go down the table?
It's going down.
The exponent's going down by how much?
1.
By 1. So down here, we're going to put that the exponent goes down by 1. Okay, the exponent goes down by 1. So I'm subtracting 1 from the exponent. What happens to what is the pattern on the right side of the table? So let me get back up there. What's the pattern on this side of the table?
Goes down by 2.
Divide by 2.
Divide by 2, right? It's divide by 2. So what would the next number be then? 1. Because 2 divided by 2 is 1. Okay, so what would the exponent be here? If the exponent's going down by 1, it would be 2 to the negative 1. So if the pattern remains the same, if I divide this by 2, what's the answer? What's
0.5.
1 divided by 2?
0.5.
0.5, or let's write that as a fraction.
1/2.
1/2. Do you agree with me that 1/2 could be written as 1 over 2 to the first power?
Yeah.
Okay. What would the next exponent be? 2 to the negative 2. If I divide this by 2, what's 1/2 divided by 2?
1/4.
1/4. Right? Do you agree with me that 1/4 could be written as 1 over 2 to the second power?
Yes.
Okay. So, what is our conclusion then about a 0 exponent? Let's get that conclusion first.
If anything is to the 0 power, it's 1.
Anything to a 0 power is always 1. X to the 0 is 1. 10 to the 0, it's always 1. Anything to a 0 power is always 1. That will always happen. What's the conclusion about a negative exponent?
It's always a fraction.
Always a fraction.
Or a decimal.
And I could write, or a decimal, but we usually write it as a fraction. So 2 to the negative 3 would be 1 over 2 to the third. Right? You see what I've done? So as soon as I flip it, it becomes positive. And then you can do 2 to the third, which is 8, so it would be 1/8. So a negative exponent just means that it's a fraction. You just flip it over and make it 1 over that power. Okay? So that's all you do on negative exponents, is make it a fraction. All right, so let's do the examples here. So what happens standard form as you move down the table? That was divide by 2. If you wanted to get that on there, this was divided by 2.
Why did you
Okay.
erase some of it and then forget to erase the rest?
Divide by 2. All right? All right, let's do the examples. And we'll try to fly through this quickly because I know some of this is reviewed for some of you guys. All right? So, right here, -5 to the -4 power, what I would recommend that you do is just go on and flip it over. And here's what everybody forgets. As soon as you flip it, the exponent is not negative anymore. It's positive. So it's 1 over -5 to the 4th power. And then, because I can do -5 to the 4th power, then I can get an answer. So -5 to the 4th power, I believe, is 625. So the answer is 1 over 625.
Yeah, it is. It seems legit.
All right, now let's look at number 3. It's a little different. Be careful on this one. I'm going to rewrite this one just so that you can see it a little better. What exponent is on the 7?
1. -1. Negative
There
x.
isn't one, it's just one.
It's a positive one.
Oh, crap.
So the 7 does not become a fraction. Only the x becomes a fraction. Okay? If I had written this like this, then I would agree with you that both of them are fractions. Everybody understand the difference? Okay, but the way this is written, only the x has the negative 1 on it. Okay? So
it
the
would be
negative 7
and
stays,
1 over x.
and this becomes 1 over x. And then I can simplify the way I write that. Negative 7 times 1 is negative 7, and then x is on the bottom. So basically, this x goes to the denominator. Everybody understand that? Okay. Okay, what do you do if it's already a fraction, like number 4? Number 4 is already a fraction. I'm going to scroll up. Is everybody okay on that one?
Is it possible to have a fraction as the numerator of another fraction?
Well, they'll want you to simplify it. Okay, so I'll show you.
I know, I was just curious.
So
Is
they
that
don't
possible?
like it written that way. Alright, so this one is negative 1/3 to the negative 2 power. So that can be written as 1 over negative 1/3 to the positive 2 power.
Haha, I was right.
Okay, now be careful. Notice that this negative is still there. The only negative that became positive was on the exponent. Okay, so make sure you don't take this negative off. Everybody understand that? Okay, so I can do 1/3 to the second power is 1/9. So it's 1 over 1/9. Now to Noren's point though, you can't leave a fraction over a fraction. That is not simplified. Okay, so this is 1 divided by 1/9. Which if you remember from some of the 10-minute things we've been doing, that's the same thing as 1 times 9 over 1.
So it would be 9.
It would be 9.
That's
So, hey, what, Brandon?
I said some of this stuff I don't understand. It doesn't make any sense.
So a negative exponent is got to be written as a 1 over that. Well, we learned from that table that that's what negative exponents are. Okay? And then 1/3 to the second power is 1/9. And then 1 divided by 1/9 is 9. Think about if you took one whole pizza and divided it into 1/9 slices, how many slices would you have?
9.
9 1/9 slices. Okay? Alright, now let's look at this. Here's what I would recommend on these problems. I would recommend starting on number 6 that you use your exponent rules before you deal with the negatives. Don't worry about them being negative right now. What kind of problem is this and what rules should we use from the other day that we learned?
Subtracting.
Subtract because it's a division problem, right? So,
Would that be r to the negative 10?
okay, look. So this is negative 3 minus negative 7. Does everybody understand what I've done so far? So negative 3 minus negative 7 is
Be r to the 4.
positive 4. So the good news is my answer does not have a negative on it anymore, and so I don't have to do anything else. So I personally don't worry about the negatives until I get the answer, and then if it's negative, then yeah, I'm going to flip it and make it a fraction. Okay? So learn all those, do the rules that you learned the other day first, and then we'll go from there. All right, so let's look at number 8 down here. Next page. Right? Okay, this one combines a lot of rules. A lot of rules. Anybody see a rule that you think we should do? Avery.
Maybe
Multiply these exponents right here. 4 times 2 is 8. So I've got m to the 8th, m over m to the 4th.
Combining like terms.
Anybody see any other rules you want to use now?
Well, you could just simplify and go up to m9 and
Okay. These two are like bases and they're multiplied, and remember that one has a 1 on it. So this one becomes m to the 9th because we should add those exponents.
Then when you subtract them,
Then we would subtract
which would turn out to be m to the 5th.
m to the 5th.
You know,
Not yet.
when we first started in high school, everyone was so comfortable. I was having confused
Let's see
about
that.
math.
All right. So that one we combined all 3 rules that we learned last time. Power rule, product rule, and rule.
Wait, did you multiply or add?
For this first one I multiplied because it was a power to a power. So 4 times 2 is 8. But this one is not a power times a power, right? There's no parentheses between those 2 exponents, right? It's just these 2 m's are multiplied together. So when these 2 m's are multiplied together, I add those exponents, right? And now there's division between those 2 m's, so then I subtract. So I had to use all 3 rules there, Leah, on that one. Okay? All right, next one.
That was pretty easy.
Next one, on number 10, what rule should I use? Multiply, because it's a power to a power here. So we're going to do negative 6 times negative 4, which is positive 24. Then positive 4 times negative 4,
16!
which is negative 16. And now I have a problem because there's a negative exponent. So I can't leave it as negative. So this is a to the 24th. Oops, I don't know why I made that 24 so big. Okay, a to the 24th times 1 over b to the 16th. So I flipped that second one because it was negative exponent.
So anytime it's a negative, put it into a fraction.
Put it into a fraction. But only the thing that's negative. Like notice the a, I didn't change it.
Will it always be 1?
1 over, yeah. So then I can simplify this to a to the 24th over b to the 16th, right? That's the simplified version of that. Okay? Everybody good?
It's easy. You just have to admit so you're
What
not
happens
used to it.
when it's like 1 over variable with a negative?
Right, that's what I'm saying, but
Close.
the blind can do it. That's not even
Maybe
blind.
we'll get there.
Oh gosh.
All right, here we go.
Done.
Darren, okay. All right, on number 13. What is raised to the 0 power?
1x.
The x and the
4.
4. So
There's a 4.
the answer is 1. Because anything to a 0 power is always
Would it be a negative 5?
okay. Now,
Or negative
listen. On number 14, what is raised to a 0 power?
The x.
Only the x. So only the x becomes a 1. So the answer is negative 5. Does everybody see the difference between 13 and 14? Kayla, on number 13, all of it was in. On 13, all of it was in parentheses, and everything had a 0 power on the outside of the parentheses. On number 14, there wasn't a parentheses, so only the x was to the 0. Okay? So both of these became a 1 on 13. On 14, only the x did. Okay? Because of the parentheses. Yeah.
Right, now for the number 13, say there are like 2 variables in
decimals in there, would that be like a 1?
As long as it has parentheses around all of it, it's
It'd
all
still
one.
be the same.
For X1.
But if you had this, the answer would be 1.
Y.
Oh, so if it's inside, it's 1. If it's outside,
Right, because all of this is to a 0, right? So it's all 1. But here, only this part is to the 0. So that part is 1, but this just drops down. Okay? All right, good questions. All right, let's move on to, is there one more example problem? Okay, at the top.
I don't really get that. Is it still 1?
Okay,
It's 3.
all right. So 3 to the 0 is 1.
It's 3.
6 to the 0 is 1. Y to the 0 is 1. And then you can add them, and the answer is 3.
No way. Oh my God.
This is some mystical crap that's going on right here.
All right. Okay, then real quickly on scientific notation. Scientific notation. If you forget how to do scientific notation, those notes are there. I'm going to explain all this to you, but this is just for your reference. If you forget, you can go back and look at
We
the
should
notes.
because we just went over it in physics.
Okay.
Yeah.
All right. I want to say something too about scientific notation in just a second that might help you with significant digits that some of you guys are having trouble with. Okay. The first thing is on scientific notation, your number has to be between 1 and 10. It must be between 1 and 10. So I have to move the decimal until this number is between 1 and 10. Okay? Wesley, where do you think I need to move it?
1, 2.
No, because if I move it between the 1 and the 2, it's 41.2, and that number is not between
Behind 2.
here.
Behind the 1.
If I move it, that's okay. Stop. Shh. Listen. Look, guys.
Oh, full 1.
Between the 4 and the 1. If I move it here, it's 412. That's not between 1 and 10. It has to be between 1 and 10. That's the first rule on scientific notation. It's got to be between 1 and 10.
What is scientific notation?
So it's just a way to write numbers.
Down here.
Okay?
He wasn't here.
Guys, stop. This is your homework time. I'll just wait. So, do you agree that my number is between 1 and 10 now?
Yes.
Okay. So, how many ever places I moved the decimal is what I put on the exponent on the 10. If this number started out as a decimal, then it's a negative exponent. And I moved the decimal 3 places. That's the reason it's a negative.
3 places to the right.
Yeah, but don't let that confuse you.
That's what was trying to say yesterday.
It is 3 places to the right, but if your original number is like a small number, then it's a negative.
There can only be one number to the left of that.
That's right. Yeah, and that makes it between 1 and 10. Okay, hey guys, listen. Guess how many significant digits this thing has?
20. Wait,
3.
3.
If you write a number in scientific notation, that you can just count how many digits are there, and that's your significant digits, always. You don't have to worry about the zeros or any of that. There's your significant digits right there.
Just like the bottom would be 1,000.
Okay, so where do I need to move my decimal, Leah, to make this number between 1 and 10?
Between 1 and 8.
No, because that's 11.8. It's got to be between 1 and 10. It's got to be between the 1 and the 1. So it's 1.18, right?
Yeah.
My decimal started at the end if I didn't see one. It's always at the end if you don't see it. How many times did I go? 3, 4, 5, 6.
So it'd be times 10 to 6.
Yeah, because this number wasn't a decimal to start with, so it's a positive 6. Okay? Guys, you can always type this in your calculator and make sure that you get this when you finish. Check it. right?
If it's such a large, if it has so many digits, it'll actually just give you back the
Yeah,
scientific
that's
notation.
true.
I think
That
I
is
remember Mr. Huntley saying that if zeros are between the numbers that go through ones between them are counted as a.
That's true. That is true, Hayden. As significant you're talking about? But how many significant digits here? Three. And let me show you something. If I had said, write 205 as scientific notation, it would be 2.05 times 10 to the second, correct?
Yes, ma'am.
That zero still counts as significant. There's still 3 significant digits. So scientific notation, you'll get your significant digits off of it.
So we just don't count it.
I counted it on that one.
It's between two.
It's between the two, and
Oh.
so, yeah, it had to be there on scientific notation. It had to. All right, let's go on to standard form. Standard form's easier, I think. Like, going from scientific notation to standard form is easier. Okay, so here, they're starting out in scientific notation, and then they're gonna want you to write it back in standard form. So 9.5 times 10 to the negative 3. If it's negative, we're gonna move to the left 3 places. And that's the reason I don't like, actually if you're going from standard to scientific, you move it opposite. So that confuses people sometimes. So remember, if it's negative, I want this thing to be a small number, a decimal. So I need to move it left. 1, 2, 3. Fill in placeholders. So 0.0095. Okay, how many significant digits? Look at scientific notation to figure that out. 2. Okay, how many significant digits on this one?
4.
4. 1, 2, 3, 4. Scientific notation will help you figure that out. We're going 10 to the positive 3 power, so we're going to the right this time. So this time we're going to go to the right. 1, 2, 3. So it's 5,748 in standard form. Okay? All right. Last 2 problems. Operations with scientific notation. Okay, this is where your exponent rules will help you out. Because then you won't have to multiply these big numbers. So do you see any bases that are alike? Any bases that are alike? Norton, your computer should be closed.
The 10.
The tens. So because those tens are alike, and I'm multiplying, I can add the exponents.
The negative 8 plus the negative 5.
That's right. So that would be
Negative 12.
13. Negative 13.
I thought it would be
So-
because it's a negative and a negative.
No, that's when you multiply, Leah. So negative 8 plus negative 5, the 10 becomes negative 13. So far that's all I've done is just added the exponents on my 10s. Now these numbers, these coefficients, I can just multiply those. So we need to do 7.5 times 3, which is 22.5. So this is 22.5 times 10 to the negative 13. I believe on Math Lab they're going to ask you to write the answer in standard form. So what do I need to do?
Go left 13.
Go left 13 places, which means how many zeros am I going to end up with?
12.
10.
11, I think, because I go 2 places and then I need 11 more zeros to make 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 2, 2, 5. Woo! Tiny number. That's standard form. Only 3 significant digits, right? All right, let's do a division one and then we're done. Okay, so do we have like bases again?
Yes.
Yes, so what do we do to these exponents since we're dividing?
Subtract.
Subtract the exponents. So for these like bases, I'm going to subtract the exponents.
When
Oh,
did we
you know
find
what?
it?
Well, I'm not going to do that, but we could have added another exponent, but I think I'm just going to do this. All right, so 10 to the negative 2, and we're going to subtract 6.
Can't you add on that other
That's what I
10?
was getting ready to say, but I think I'm gonna do it this way. So that's 10 to the negative 8. Okay,
Okay.
now what is 5 divided by 10?
2.
No,
5 divided by 10.
not 10 divided by 5, guys.
0.5.
0.5. Okay, then in standard form, I've got to move the decimal back 8 places. In this case, I'm going to have 8 zeros. Doesn't necessarily mean I have 8 zeros, but this time I will. 4, 5, 6, 7, 8, and then 5. That's standard form.
You still haven't answered my question.
All right, what was your question?
What happens when it's 1 over a variable with a negative exponent?
This goes to the top and becomes x to the positive.
So it's just x.
It just flips over.
Okay.
It's really 1. It's 1 over x to the 1, right? Does that make sense? But 1 divided by 1 over x to the 1 is 1 times x to the 1, which is x over 1. Let me stop this recording, Madison, and then I'll get you. I mean, yeah. Oh, is it? Yeah, I thought Madison had her hand up, right?
Oh, I think you're saying.
This is great.